Hello everyone, this is Jayashree. I'm starting with a new chapter, Real Numbers, from 10th grade NCERT book. Hoping this will be very useful for all 10th graders. Let's continue with this chapter. In this chapter, the very first theorem and important theorem, 1.1, which also called as Euclid's division lemma. And the statement of this theorem is, given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is greater than or equal to 0 but less than b. R is greater than or equal to 0 but less than b. Okay, to understand this theorem statement clearly, let us do some simple small calculations like 10 divided by 3, where 3 and 10 are divided like this. 3 3s are 9. So 1 is the remainder. Here 3 is called quotient, 1 is called remainder. Or I'll take another example, 23 divided by 4. In this example also, let us divide 23 with 4. 4 5s are 20. Remainder is 3 here. So here 5 is called quotient and 3 is called remainder. And similarly 81 divided by 3. Here also if you divide 3 and 81, 81 is divided by 3, 3 2 6 and 2 remainder, 1 3 7 is 21. So here 0 is the remainder, 27 is the quotient. So to understand these divisions, so you already know that in the previous classes that to get this dividend, the middle number, this we call as dividend. 10 is equal to multiply divisor. This 3 is called divisor. Divisor multiplied by quotient. These two numbers will multiply and add the remainder to that. Remainder is here actually 1. So let's remainder write as 1. So similarly 23 divided by 4 also. We can write 23 is equal to the middle number dividend is equal to 4 is the divisor here. 4 times quotient 5 plus remainder 3. Similarly 81 is equal to the dividend 81 is equal to divisor 3 multiplied by the quotient 27 plus remainder 0 here. So this is nothing but we call as division algorithm. What do you call this as? Division algorithm. Algorithm is a series of steps to solve any problem. Algorithm means algorithm is a series of steps which are useful for solving any type of problems. So here to divide we are using some series of steps. So dividend is equal to divisor, we write it as dividend is equal to divisor, I am writing dr, divisor multiplied by quotient plus remainder. So this is called division algorithm. If you observe carefully, our theorem statement also is the same as this. In this case, if a is divided by b, if a is divided by b, here a is the dividend, b is the divisor, and let us think q and r are quotient and remainder respectively when a and b are divided. So then dividend a is equal to divisor b times quotient plus remainder, which is same as our division algorithm. Dividend a is equal to divisor b times quotient q plus remainder r, which is same as our relation given in the theorem. Now let us read the theorem statement once again. Given positive integers a and b, there exist unique integers q and r satisfying the relation a is equal to bq plus r, where r lies between 0 and b. Now let us use this Euclid's division algorithm to calculate HCF of two positive integers. For this, let us take a question. Calculate HCF of I am taking two positive integers 455 and 42. For this, generally how we will do by long division method, take these two numbers and we'll divide one with one each other, right? The smaller number will take as divisor, the bigger number will take as dividend, and we'll divide these two to find the HCF. This is called finding HCF using long division method. Okay, let's recall that and let us apply this to division algorithm theorem. Okay, let us see first. 42 times 1 gives you 42. Subtract 3 gives 5, 35. So 35 is the 42 zeros are 0, smaller than 42. So I'm taking zeros are 0 and 35 is the remainder. Now take this remainder as the divisor now and take this previous divisor as dividend here. Okay, again 35 times 35. Ones are 35. 7 is the remainder. And next, take this 7 as the divisor and take this divisor, previous divisor as dividend and continue the division until we get a 0 remainder. 7 5 35. Yes, you are getting a 0 remainder here. So what do you mean by this? Here, at this stage where you got the remainder as 0, the divisor at this place, at this stage, the divisor we call it as HCF. Right? So now let us see, for each division we will apply division lemma. The theorem 1 division lemma will apply. Here for step 1 and the first division, step 1. Here 455 is the dividend. So let us write 455 equal to, divisor is 42. 42 times quotient is 10 plus remainder is 35. So this is the division lemma we are applying for step 1, like for first step of the division. Next, in the second step of division, this is first step of division, this is the second step of division. Step 2. Here the dividend is 42. So 42 is equal to 35 is the divisor, 35 times the quotient 1 plus remainder is 7. Okay, this is the division lemma applied for second step of division. You have one more step, third step of division. In the third step, you have dividend as 35. 35 is equal to 5 times 7 or 7 times 5, divisor times quotient plus remainder 0. So whenever you are getting 0 as remainder, then we call HCF as, the divisor is the HCF. So HCF is equal to 7. This is the HCF. HCF is 7. So from this example, you can understand that to find HCF of any two positive numbers, let us take A and B to find the HCF of any two positive numbers. Or any two positive integers, say A and B, where A is greater than B. Applying this theorem, Euclid's division lemma, you can write step 1 as A is equal to, if A is divided by B, so you can write A is the dividend. A is equal to B is the divisor times quotient plus remainder, where Q and R are, where Q and R are whole numbers and R is lying between 0 and B, right? Okay. Now, if in this case, if you get 0 remainder, B would be the HCF. In this case, if remainder is 0, B would be the HCF. So, let us write step 2. If R is equal to 0, B is the HCF. But if R is not equal to 0, we need to go for step 3. If R not equal to 0, then continue the process for B and R. Then continue the process for B and R. Taking B as for B and R. Taking, now the remainder is becoming as divisor, that the previous divisor B becomes as dividend, and we have to continue the division by taking some quotient what you will get and with the remainder. If remainder is not equal to 0, we need to continue the process like this until you get remainder as 0. Until remainder is 0. At what stage you get remainder as 0? In that stage divisor would be the HCF. So let us take this prove this division lemma with some more examples in the next video. Bye.